Hello and welcome back. In this video we'll be talking about the second topic in applied calculus, which is functions. And we'll start with the definition. This is a slightly technical definition, but I'll talk us through it. A function is a relation that assigns to each member of the domain, which are the inputs, a member of the codomain, which we think of as the outputs. In my mind, I think of a function as a machine. You plug something in, you give it an input, the machine will take it and spit out an output. And it has to do so consistently. If you give it the same input over and over again, it will spit out the same output. So there's a very specific rule that the function follows. And we can do this a little bit pictorially. So here I have the possible inputs are, so the domain are just 1, 2, and 3. Here, our codomain, all the possible outputs are A, B, and C. And what I can do is I can say, okay, so given my function, maybe I'll call my function f. If I give it a 1, it has to spit 1 as an input. It has to come out with an output, one of these three choices. So I could maybe make a function that if you give it a 1, it spits out an A. If you give it a 2, maybe it spits out a B. And maybe if you give it a 3, it also spits out an A. So again, every time we give our function a 1, it should spit out exactly one thing, and we've chosen A. The 2, it'll spit out a B, and a 3, it'll spit out an A. Our notation for this is if we have our function, which we call f, we write our input right next to it in parentheses, and the output is just going to be what this is equal to. So we have our function f, we plug in a 1, we get A. We have our function f, we plug in a 2, and we'll get B. Have our function f, we plug in a 3, and we will get A. So here, there isn't really any rhyme or reason behind why we chose these things. It's just our made-up function. What you'll notice is that C, nothing maps to C. There's nothing in the domain that gives us the letter C. So the range of the function is going to be the set of all actual outputs. So here, even though C, it would be possible to get it, it isn't actually an output of anything. So when we look here, we have the domain. The domain of f is going to be equal to the set of 1, 2, and 3. It would be all three of those things. And then the range is only going to be A and B. So here we can't get C, so we don't include it in the range. We still have a codomain, and the range is going to be slightly different. The range is going to be a little bit more useful to think about in general than the codomain. And by and large, almost all of the functions that we'll think about in our class, our domain and codomain is going to be made up of numbers. So we're not going to see a codomain consisting of, say, letters or shapes or words or anything like this. And again, in this class, we're not often going to specify the domain of many functions because it's just going to be understood. And if we don't say exactly what it is, we're just going to assume, okay, it's as big of set of numbers as we could possibly fit into the function. Sometimes we're not allowed to plug certain numbers in. So for instance, let's start with the second function down here. Our function, our rule that we're going to use is we're going to take the reciprocal of whatever number we plug in. So for instance, if I plug a 2 into my function, I'm going to get a 1 over 2, so half. If I were to plug negative 1/7 into my function, I'll get a 1 over negative 1/7. And using fractions, we'll see that this is actually negative 7. So we're just plugging in numbers and seeing what we get. The domain here is just going to be all the numbers that we can plug into this function. And there's one number that we can't. We can't divide by 0. So if I try to plug a 0 into this function, we're gonna break things, and I'm going to try to divide by 0. So the domain should be every real number except 0. And the way that we input this is going to be as follows. We're going to have every single number that we can ever think of, from negative infinity up to 0, but not including 0, and a 0 to infinity. So the notation here, parentheses mean we're not going to include the thing right next to it. So first of all, why don't we include negative infinity? It's not a number. We're not going to plug it into our function. Why don't we include 0? Because we can't divide by 0, so we're not going to include it. Again, I can't divide by 0, so I don't want to include it. And infinity isn't a number, so I'm not going to plug it into my function. Furthermore, this funny symbol in the middle means union, and when I take the union of sets of intervals, it means that we're going to put them together. So I'm going to take all of these numbers and all of those numbers, so I'm going to put them together using the union. If I draw a little picture of what this looks like, the graph of 1 over x, again, here are all the x values and here are all the y values, is going to look something like this. And we have an asymptote. So as we get closer and closer to 0, we're going to shoot up if we're coming from the right, or if we're coming from the left, we're going to be shooting down. So the range is going to be all possible values that we could ever get. So the values, the outputs of our function, we're going to use y, the y-axis, to represent these. So then the question is, okay, so here's a y value right there. Can we get it? Yep. Right there. If we plug in this value of x, we get that value of y. Maybe here's another value of y. The question is, can I get that? Is this in my range? Is this an output of the function? And we go, yes it is. If I plug in this value of x, I will get this value for y. And what you can see is that we can go up as high as we want, so we can get all the big numbers. We can go down low as far as we want, so we can get all the really negative numbers, but we never quite hit 0. There's no number that you can plug into this function to get 0. 1 divided by, no matter what you plug in, if you take 1 divided by a number, it's never 0. So this function actually has the same domain and range. We can get every real number except for 0. Let's come back up here and look at this function. This is maybe a little bit simpler. So all we're going to do is this function, when we plug in a number, we're going to square it. Okay, that's pretty straightforward. So the question is, what is the domain? What are all of the possible numbers I can plug into the function? Well, I can square any number that I want. There's no restrictions. I can square positive numbers, negative numbers, I can square 0. Every single number works. So all the way from negative infinity to positive infinity. Cool. So then we can ask, what is the range of our function? So what are all of the possible values that our function can take? So again, I think maybe the best way to do this, I'll erase this down here, would be to graph the function, and let's see what are all the possible values that I can get. Well, this is a function that we've probably seen graphed before, and it's going to be something like this. If I could draw a nice curved line. Apologize, freehanding is not my strong suit. So x squared is going to be a parabola shape here. And again, we have all the x values and all the y values, and what you'll notice is that no matter what value I plug in for x, it always seems to be above the x-axis, and it's never going to be below the x-axis. Why? If you square a number, it becomes positive. So for instance, if I take a positive value for x and I square it, we get a positive value for y. If we take a negative value for x and we square it, a negative times a negative is a positive. So we can get all of the positive numbers. We go up and up and up and up to the right. We're going up and up and up to the left. Right here at the base, though, if we plug in 0 exactly, we can get 0. So what are all the possible values? We can get anywhere from 0 to infinity. And again, I don't want to include infinity because infinity isn't a number, so I'll use a parenthesis. But I can get 0, so I do want to include 0. I use a square bracket for this. So the square bracket means that I will include this inside of the set. So here I will use, I'll have from 0 to infinity, including 0, but not including infinity. This is just a brief introduction to domain and ranges. We can also look at domain and ranges just from a picture. So again, the way that we interpret a picture is that our inputs are going to be along the x-axis. This is why we use x for the inputs into the function, and y, the height of the function, is going to be the output here. So when we're looking at this, this is going to be our entire function. We've got this line that comes up, touches there, and then comes back down. A couple of things to notice. Wherever we have a big circle, that's just indicating that our function exists there. Here we have an open circle, which means that this is not a place where the function exists. So let's look at the domain. So again, the domain is all of the inputs, so along the x-axis. And these will stretch from, say, right here, which is at x is equal to -2. And we can plug all the values in up to here, which is at +2. So again, we can go from -2 all the way up to +2. There's a filled-in circle at -2, so I can include that one. But I can't include 2 because it's an open circle. So I can plug in every number up to it, but not including 2. Secondly, the range. The range is going to be all the possible values for the heights. So again, the lowest possible value is going to be down here. This is going to be at what? -1, 2, 3. And I can go all the way up to 2. So I can get every value in between. So my range is going to be from -3 up to 2. And the question is, do we include them? Well, yes, I can get -3 by plugging in -2. That works, so I will include that. And then the question is, can I get 2? Yes, if I plug in 0 in for x, I will get a height of exactly equal to 2. So this is also going to be the square brackets. So again, when we're looking at this, we can interpret the specific values as well. F of -2, if I come over here to -2, we already saw that we got -3. If we come to -1, we're at a height of 1. And at 0, we've come up to 2. So we can read a lot from a graph, remembering that the x-axis is going to be the inputs, and the y-axis, the height, is going to correspond to the output of the function, the range. And then the last one that I'll do in this video is just going to be a quick square root function. So what we want to remember is that we can only take the square root of positive numbers. So when we look at this, I can only plug numbers in for x that make this positive. So what I need is that 1 minus x needs to be a positive number, so it needs to be strictly greater than 0. And then from here, we can deduce a few things. So one is that I can subtract 1 from both sides, so we get -x is going to be greater than -1. And then if I want to figure out exactly what x should be, I could multiply both sides by -1 to cancel out the negative sign, remembering that if we multiply or divide by a negative number, the inequality will switch. So every number that's less than 1 I can plug in. Okay, so what are all the numbers less than 1? Well, it goes from -infinity up to 1. And again, this is strictly less than 1, so I don't want to include 1. The range of this function will be all positive numbers, but only positive numbers, not including 0. The range of a square root function by itself is always going to be positive numbers. I can get every positive number as a square root, and we haven't affected the height of our function.